A sort of mass 80 kilograms standing in a lift. What force does he exert in the floor when the lift is at rest? So if you look at Osoro inside a lift, let's draw Osoro here. If the lift is not moving, so let's say we put some scale there. So Osoro will weigh mg, which is mass times force of gravity. This will be 80 times 10, giving us 800 newtons. This is actually 80 kilograms times 10 newtons per kilogram. So that per kilogram and kilogram cancel, you remain with the units as newtons. Now, this is going to be an issue if the lift accelerates upwards. Now, this 800 newtons is actually reaction on Osoro. Remember, there will be a reaction of 800 newtons negative, while action will be the weight and 800 newtons. So what we see as the weight of this gentleman that is being registered on the scale is actually the reaction of the floor on his feet. So that if the lift now is moving upwards, then what happens is that the floor, the acceleration will be 4 meters. A is equals to 4 meters per second, per square second. This acceleration will have a force given by ma. So there will be a force given by ma, and this force is actually acting on the feet of this gentleman. So that ideally the reaction on Osoro in that direction will be R prime. And this R prime is more because we have this extra force here because of acceleration upwards. So the extra acceleration comes from ma, so that instead of weight now, which is reaction, we shall say that R prime is given by mg plus ma, because it is more, we have more reaction on this gentleman, and this is the apparent weight on Osoro. So in this case number I1, the reaction is equivalent to weight. But in this case, the reaction will be more. That is why we are adding force due to acceleration given by ma. And in this case, this will be m into g plus a when you factor out m. And we were having 80 into 4, 10 plus acceleration of 4. So this is 14 times 8, which is 140 times 8. If you calculate this one, 8, 32, 11, 20. This gives us a value of 1120 newtons. So ideally what happens is that Osoro weighs more if it is accelerating upwards. Now, if it is accelerating downwards, that means the floor is not pushing on you because it is moving away from you. And therefore, the R will be less than the actual weight. So this is what we call apparent weight. And 800 is the actual weight. So if the lift accelerated downwards with this value here, that means it will weigh less. So let's call it R prime prime will be same as its weight, which is mg, and then you will subtract force due to acceleration downwards ma, so that it weighs less. And therefore, in this case, this will be m into g minus a, and in this case, it is just 80 into 10 minus 3, which is 7, 10 times 7, 80 times 7, giving us 560. 7 times 4 to the 8, 56 weighs 560 newtons. So sort of weighs less. But if moving upwards with constant velocity, if it is moving with constant velocity, that means acceleration will be zero, and therefore there is no resultant external force due to an acceleration. And therefore, for this, you will still weigh 800 newtons because there is no acceleration. There must be an acceleration for us to have this F that either adds to or is subtracted from the actual weight for us to get the acceleration. For us to get the actual weight or the apparent weight. So in this case, R prime and R prime prime is the apparent weight that you can easily calculate in that manner.